virtualization, there were massive server farms that required lots of power. They were very space inefficient, they were very power inefficient, they were very resource intensive, and there was lots of wasted resources. The biggest problem that led to virtualization was lack of use of simultaneous users, meaning more than one user could not use a single set of resources at the same time. This led to the idea of time sharing, but that was just one of the ideas they had going on at the time. Another one that came from, I believe, IBM, essentially led to what was Java and the first virtualization, which was software virtualization, which allowed for you to have multiple applications set up across the board for any device and exporting it only once. What Java basically is it creates its own environment, a virtualized environment within the operating system, and allows anything to run within that code as long as it's been precompiled and all that. Java was really the first form of virtualization, and it wasn't quite what we think of virtualization today, but what came out of it was more kinds of virtualization. The next kind that came out of it was Unix, which was a user-based virtualization. So what it did was it virtualized, you could have multiple simultaneous users by virtualizing their desktops, but from one system. This led even farther into what we mostly commonly refer to as virtualization today, is server virtualization and workstation virtualization, which is what you would think of with big server farms, massive amounts of data being processed, massive amounts of workstations for many users, all on either one or multiple systems, but all provisioned together to function as one and then distributed out as many. Virtualization requires a few things. You need the hardware to put the software on. The next thing you need, which can be a firmware-based, software-based, or hardware-based, what's called a hypervisor. And this hypervisor is what provisions out all of your different resources, and then everything is created from that, as you can see in this image. You can create different VMs, different instances of an operating system, and then just treat it like any regular computer past that. There are two main types of virtualization, most commonly. There is type 1, which is the native virtualization. It's where instead of putting like let's say Windows over on a set of hardware, you put a custom software as the operating system, and that acts as the hypervisor that we talked about earlier. And it requires a little skill between. It's called native because it runs directly on the hardware. There's also a type 2, which you have what's known as your host OS, such as, let's say, for instance, Windows. Then on top of Windows, you install an application, and that application then acts as your hypervisor. And then the virtualization comes out of that.
Now that we've gone over the basics of virtualization, we're going to get a little bit more specific and talk about VMware virtualization. Our organization uses a vBlock for its VMware virtualization environment. vBlock houses all of the hardware that's needed for a virtualization environment, including your compute, your networking, and your storage. Now I'm going to go over the different parts that make up the vBlock and give you various details about each component. First, I'm going to go over our storage, which we use EMC VNX series SANs and to connect all of our virtual machines. Right now, in each bay combined, we have about 200 terabytes of capacity, and each of these are linked to the servers using fiber channel. Next up is the compute. We currently use Cisco UCS servers. Each server is a blade server, and each server has 400 gigs of RAM and 2 Xeon processors that each have 8 cores. Our SANs also support auto-tiering, which is essentially quality of service, but for storage. Operating system disks will get the fastest storage, or the 21,000 IOPS disks, that will allow them to perform their tasks better. Next, we're going to talk about the networking aspect of the vBlock. First off, these two switches right here are fabric switches for the management network. The actual switches that run the V-block are actually part of the compute UCS blades. They actually connect each piece from the compute to the storage using a 10 gig backplane.
A V-block is incredibly expensive and incredibly complex, as you can see here. Most small to medium-sized companies do not need something this extensive. And you can virtualize in a much cheaper and more efficient manner using software-based virtualization such as VirtualBox and many others that don't require this massive amounts of expensive and complex hardware.
First off, that involves using vSphere. vSphere is the client that actually allows us to access all of your physical hosts that house your hypervisor and allows you to provision your desktops and your servers. Okay, now we're going to log into the VMware vSphere client, and I'm going to show and describe parts of this client. Okay, first off is the VMs and templates, and this view gives you the actual server view. Each of these are individual virtual servers, and as you can see, it shows the guest OS, it shows the VMware version, the CPUs, the memory, and the IP address, and also the DNS name. And this is a good way to categorize all of your servers and keep track of them. And then another view is the host and cluster view. And this view actually shows you the physical servers, the physical hosts that you have added to this environment. So right now we have 6 physical hosts. Each host actually has 2 processor sockets, 8 cores, and 32 logical processors altogether, and close to 400 gigs of RAM. And the next view that's really important is the networking view. In VMware, you have to set up virtual port groups to simulate VLANs. Without these, your systems won't be able to communicate to the network. And now we're going to go to the last section, which is data stores. And basically data stores, this is storage that's been provisioned from a SAN, and then that provisioned space you actually create a data store out of. And for example, this data store has the capacity of 5 terabytes. Right now the provision space is 4.46 and the free space is still 3.94 terabytes. Okay, we're going to go ahead and provision a new server using vSphere client. First off, the great thing about VMware is they allow you to use templates. And basically what a template is you create a server based on the OS, say 2008 or 2012, and you go through and install all the updates, you configure it the way you want. After you're done, you power that machine down and you convert it to a template file. And that's what this is right here. So now you click on the template file and you click deploy to new virtual server, and we can go ahead and give it a name. So we're just going to go test-server, and now it shows you the VMs and templates view. So now you can choose which folder to put it in. So we're going to go ahead and put it in the server folder. And then you must select the cluster. And basically what that means is that's just all of the hosts put together are called a cluster. And we'll hit next. And now we need to select the proper data store. And I already have that named OS v1. So we'll go ahead and hit next. And now you can customize it. And basically what a customization template does is in a lot of servers, if you just keep duplicating the same server over and over again, the SID number will be the same. And if anybody's familiar with SIDs, the SID has to be unique for every single computer on the network. If not, you end up running into authentication issues. So I already have one created for my Windows 2012 R2. I'll go ahead and hit next and finish. And then at the bottom, it's provisioning the server. So next we're going to talk about virtual workstations. Our organization, they actually use about 350 virtual workstations. We have a big call center, and they found that it's cheaper to use virtual workstations with a thin client than actually buying separate PCs for each individual. Our organization uses VMware Horizon to deploy its virtual workstations. Let's go ahead and log into the web client, and I can kind of show you around. Okay, so here's the main dashboard view. You have your connection servers, which a connection server is actually what each thin client, or we call them WISE boxes, connects to in order to access its virtual workstation. You then have the View Composer servers, which a virtual desktop needs to be recomposed approximately every 2 weeks, and this is to install new updates or newer versions of software. And next, let's go to the pools. Virtual desktops can be categorized in pools, and as you can see here, our call center pool, and right now this pool has 150 virtual machines. We have 2 spares, so if we hire new call center people, they will actually automatically be assigned a new virtual desktop. And as you can see here, it actually gives the username of the user assigned to each virtual machine. Okay, and lastly, I want to go over VMware's virtualization benefits. And this includes clustering, vMotion, distributed resources, and distributed switching. Okay, let's go to the vSphere client and I'll show you those. In vSphere, you're allowed to create virtual switches that control all of your VMs. So here we have a virtual switch called DV Elixir, and underneath the virtual switch it supports these VLANs. Now we'll go to the VMs and templates, and I'll show you how to assign the virtual switch. You go to Edit Settings, and you go to your network card, and down here, Network Label is the drop down of all the virtual VLANs that are housed in that virtual switch. And once you select the virtual VLAN you'd like to use, you just go ahead and hit OK, and then that updates the network card within the virtual machine.
Our organization uses virtualization for many reasons. The first of these reasons is that it's much more efficient to use virtualization. It's much quicker to provision desktops, provision servers. There's a lot less downtime or preparing time to get those to the end user or get them into production. The second of these reasons is that virtualization allows for a much more central management system and allows for, it makes it easier to expand your servers. What I mean by this is, let's say you need a new server, instead of waiting around for more hardware to upgrade that server, because let's say you had an increase in users or something to that effect, you can just go to the management console, and with a few clicks you can add more RAM to that server in minutes, as opposed to waiting weeks for new hardware.